Right. So a recap of what we were doing in last class. So it was like reinforcing front-end concepts, front-end terminologies. Okay. It was only about reinforcing front-end terminologies. So that was the main idea. So slowly we were. Is everybody able to hear me? Shilpa able to hear me?
Yes, sir.
Okay, and the word file is also clear?
Yes, sir.
Thank you. Right, good. So the last two classes were all about reinforcing this idea of front-end technologies and how they are useful and how they should be actually standardized. Without standardization, it will be very difficult and there won't be any big growth there. So that is why the beauty of standardizing RF front-end. Anybody has got any doubt in this or any clarifications you would like to tell? Or anything you would like to know? Because still we are not gone into the actual thing. Just gave you some examples regarding why you should study this subject. And did anybody go through the project Loon and all, where Google and Facebook were trying to create front ends of their own, maintaining your thing correctly? Did anybody take that pains to look at it? They have anyway disbanded that. Yeah, anybody is there? Yeah.
Yes, sir.
Yeah, who's that?
Sir, Gayatri, sir.
Gayatri, பாத்தீங்களா என்ன சொல்றாங்க? What are they telling there?
Sir, they told like they were trying to establish a balloon like in rural areas to give internet, but then they dropped that project because it was very costly.
Yeah, that is it.
Yes, sir.
So finally for the entire class, what I'm trying to tell you is, see how even big companies like Google and Facebook couldn't do anything if you try to play with the front end, because such is the standardization level that has been achieved there and technology has grown up on that. Now if you try to do something with the front end, you have to do lots of work. Okay, so try to get the feel of it, and this feel should be there throughout the subject. Clear? So that's why again going back to the first class where I said we are going to study a subject in which we are going to tackle front-end problems. We are going to study parameters that are easy and how to tackle front-end commercially. Clear? So in today's class, hope everybody is clear with the base on which we are going to work. So in today's class, we are going to start off with something called as matrix representation. Matrix representation of devices. Right? So this is how the subject officially starts off. You have to know if I have an amplifier or any filter or anything, how to have a matrix representation of it. So here device means any electronic component, used in front end. Right? So this is the idea. It may be antenna. It may be a small transmission line bit, or it may be an amplifier, or it may be a filter. Right? Now, for all these devices, we have separate terminologies, but here we are going to see something called as a matrix. How to attack these devices through matrices. Clear? And the industry has identified many types of matrix representations. Right? So the first one is a scattering matrix. Just note down these names. Scattering matrix. Then you have impedance matrix. Then you have impedance matrix. Then you have something called as admittance matrix. Right. Then you have the fourth one is ABCD matrix. Right. So you have lots of these matrix representations, clear, in which the most successful, the most accepted matrix. We'll be studying a bit about all these things, but not that much. The idea of scattering matrix. The idea of scattering matrix representation, right, is the most popular, right, accepted commercially, accepted by industry, right, and easy to determine. Right. So this is what we are going to see first. The first idea of describing a front end, right, starts with trying to give a general matrix type representation to any device. Clear? And in that, what is a matrix and all those things, we'll be slowly getting into it. Don't worry. Clear? So at present, we'll have to start the subject like this. We will not be talking anything about gain or whatever radiation pattern or nothing like that. Clear? So that is the idea there. That is what you should understand here. So we are going to give a brand new representation to the transmission lines or antennas or amplifiers or filters that are going to be used at front end. Clear? And that is what you are going to study as the first topic. And therefore, if you get into any of these industries, you will be just worried about the S matrix of devices. They call it S matrix also. That is a name that we'll be using. Scattering matrix is also called as S matrix. Right. So this is what you should be comfortable. And this is our first topic. How to, if I have a device with me, how to get the S matrix out of it. Right. By the end of this topic, you will understand that if you know some analytical aspects of the device, then you will be able to write the S matrix. And then you manufacture the product, you measure the S matrix and give it to the customer. So this is how front-end technologies go. All right. So now you should have understood that the vast majority of electronic applications, we have brought it to one single representation. Clear? So now it has become easy for industry also. Clear? It is really easy. It is easy for industry also. Right? So if you are manufacturing something for D2H industry, you know what is the S matrix required for it. If you are manufacturing an amplifier for a D2H industry, you know what to manufacture. Clear? And if you get into that industry, you will know how to relate the S matrix to the amplifier parameters and you can easily go into it. Anybody has got any doubts in this? Anybody has got any doubts in this? This is the main thing. So any academic terms, it's not that I'm telling it's not unwanted and all. Any academic terms like gain, input impedance, output impedance, right? You will be getting into S matrix. And you will only talk in these terms. You will not talk in these terms. So this is the idea. So this is going to be our first topic, S matrix, right? In this, we will be studying why S matrix became popular. What is the need for this thing? All those things we are going to study. So what are you going to study? Why S matrix, right? S matrix formulation, right? And the features of it. Features of S matrix, that makes it popular. Makes it easy or popular. Either way you can take it. Right. So this is going to be your first topic there. Right. In the first unit, first topic. In the syllabus, it is given a matrix description of devices. So this is what you are going to see there first. Clear. Now we'll just get into the idea of history of matrix representation. You need to know why these things came actually. History behind matrix representations. Right. So what is the history behind matrix representation? Clear. It is mainly, this is a small story there, but you need to understand appreciate the idea there. So it was definitely during the Second World War. Actually, any tragedy only creates technology, right? So in Second World War, you had the amplifiers and circuitries, right? Basically the idea of radar. Aditya?
Yes, sir.
Aditya, what does a radar do?
Sir, general meaning you're asking. General, what does it do, sir? It detects any ships or anything. It's coming aircraft, sir.
More better, you transmit a wave, wait for the reflections, and
yes.
based on the reflections, you decide what is the object or anything. Correct?
Yes, sir. How far is this?
Exactly. That's all. That is all. More, not more. So you have to transmit a sufficiently high power electromagnetic wave. Getting it? Because
yes.
You are worried about the reflections. Correct? Correct.
Yes, sir.
So for the entire class, what I am trying to tell is why they went into this matrix idea. It's quite a interesting thing. I'll tell you from where you got these things and all. By today, I'll be introducing you to the textbooks and all those things. So these radar applications, it is nothing but first of all a transmitter. So you needed a big setup of transmission line and an antenna. So antenna is there. The basic problem came when you had waveguides. Right, this is how the idea of front end, we have to take away front end from everywhere and make it standard came into picture. See, a waveguide, if everybody remembers correctly, if you are processing the energy in the form of wave, we can pass it through small metallic tubes. This I think you should have, if you have forgotten the things in 4th semester, I am trying to remember it. Clear? So you give an EH and you get an EH. Right, we would have studied, please remember, waveguide is preferred over TL. TL means transmission lines for really high power applications, really high power. Right. Now, can anybody tell me the idea behind this? If the power levels are really high, the transmission lines are replaced by waveguide. Power level, I am not talking about the frequency level. Does anybody know the reason for it? Because these are all holistic things that you should know to appreciate the subject. Can anybody get this?
So dielectric breakdown will take place in the case of a transmission line if a high power is being transmitted.
Fantastic. So just like that, I am trying to reinforce what Samukta said. If you have a transmission line which is nothing but two metal pieces which is supported by a dielectric, when you give high power, right, the dielectric breaks. The dielectric breaks, right? This results in two cables shorting, cables or wires getting shorted. Right, so this led to the idea of waveguide, because in waveguide it is air dielectric, so there is no way that you can have the issue there. In waveguide, air dielectric is used. So we can have the capacity for sufficiently high power. Air dielectric is used. Right. So when waveguides are used, right, I think we slowly, I think we wanted to enter into that. We took parallel plate waveguide, we took rectangular waveguides, but by the time the institute closed down and we couldn't finish it off. See, waveguide analysis is quite hectic. Analysis of waveguide is really cumbersome. I'm just putting it directly as a bolt from the sky. Why it means? Because you have to keep on solving Maxwell's equation inside a waveguide to do any design and analysis inside a waveguide. Right, but the World War condition was such that the World War II condition was they required quick results. They required quick results. They can't wait for all this applying the Maxwell's equation inside and doing what is this. No, nothing. They didn't have time for those things and all. Right. So when the front end was damaged, the waveguide which was supplying power to the antenna was getting damaged frequently. They wanted new replacements. So they wanted quick results. This was the primary idea of primary motivation behind matrix representations. Right. So what they did is they saw waveguide and any component as just a 2-port network. Right. So the idea was clear. Basic idea of matrix representation. Basic idea of matrix representation is look at any device. Look at any device as a simple 2-port network. Right. What do you mean by that? Don't worry about what is happening inside. Clear? Just get the input-output relations. Don't worry about solving Maxwell's equation inside and out. Right. Just try to observe input-output relations alone. Input-output relations. Right. So this is what they try to do there. Don't worry about doing all the internal things. So suppose a waveguide got damaged. They did a small trick to it or small design change in it. Now don't go and do Maxwell's analysis and all. Just try to observe if I give this much input, what is happening at the output. It was more or less a trial and error method. What they did is they standardized a machine, a measuring device. This was standardized. They standardized a measuring device whose name is given as vector network analyzer. Vector network analyzer. Please try to get this idea correctly. A device was found out. Clear? VNA. This is usually given the short form VNA. Right. So this network was kept there. This is your VNA. It has 2 ports, port A and port B. You take any device under test, connect it. Right. This provides an S matrix. Right. That's enough. Clear. So the basic idea behind a matrix level representation should be very clear now. Clear? The front end was mainly composed of waveguide based devices because of high power. Clear? Why high power? Because it was fully of radar applications. That is where it all started. You have to understand that. After Second World War went away, got over, people saw the beauty in these techniques. And when they were trying to create more and more nice commercial devices, clear, for civilian applications, they wanted to use whatever concepts they found out using Second World War for making money through civilian applications. So that is how this idea came. That's why I'm bringing the idea of Second World War. Don't think that we are going into war and all. So during World War, to replace the waveguides, to service the front waveguides quickly, they adopted this standard. Create a machine called vector network analyzer. Now you don't worry about what it is. This vector network analyzer gave simple input-output relations. What do you mean by that? It said if I give this as input, this is the output. If I give this as input, this is the output. That's all. Right? So they programmed it there. Now what they did is you don't need to do this. DUT was most times a waveguide. Most times a waveguide. So what those guys did is just make any change in waveguide, connect it to VNA, see if the thing is working perfectly. They never went into analytical techniques. Clear? So this gave rise to the matrix level representation. Getting it? Is the idea clear? So that became standardized as something called as S matrix. And this is what we are going to study in formulation of S matrix. Right, getting me? Please take efforts to understand it. I am told you we are studying about a commercial thing here. Right? We don't have time for solving Maxwell's equation inside the waveguides and getting results. So they decided that we will create some systems like this, where any small change in waveguide, you want to see what is its input-output relations. I give this much wave, I get this much, finished. You don't worry about anything. Right? This technology is what went into, then afterwards this DUT became any amplifier, filter or anything, transmission line or anything. Is the idea clear? Samukta, is the idea clear, ma?
Yes, sir.
Right? The problem of doing usual EM analysis was overcome by designing one device called vector network analyzer and then believe whatever the VNA says. Is the idea okay? Right.
Yes.
So, okay, Harshavina. Harshavina is there? Harshavina. Okay. Right. Venkatesh, you are there? Venkatesh. Venkatesh. Rohit. Rohit is not there. Okay. Good. Is there any company going on today? Has anybody gone there? Is there any issue in that? Please tell me. Otherwise, I'll be noting down things and I'll be just going on my own way. See, please be understand that. Right.
Sir, I joined a few minutes back.
Okay. Right. That's okay. Clear. So today's class was a bit of storytelling only. But anyway, you should understand because tomorrow when you take the S matrix formulation, it depends. Basically, if you don't understand that there was a device called VNA, which created all these things, S matrix formulation, you will not find it easy. You can study it as a mathematical tool. Absolutely no issues. Nobody is going to tell anything. Without any appreciation of the concepts, you are welcome to study. My main aim is to make your life quite a bit interesting. How the idea of, see, if I just give you a waveguide and see, let us just take this example. I will just go along like this. See, you are using, let us do just to confirm it, you are using an amplifier or you have full transmitter. An amplifier is there, an antenna is there. Clear? Here you are using a waveguide. Clear? Now something happens here, some issues arise. Right? Now, if we get into EM analysis, it's really sad. If we get into EM analysis, sit there doing it, we'll be always left with open-ended mathematical equations. If we get into EM analysis, it is really time consuming. Please understand that. Right, so that is where they decided on this matrix representation. And how was the matrix representation? Through standardizing a device. Right, so a matrix representation through a standard VNA. Solved the idea. Able to get it? This is how you should understand. And this only went into amplifiers and other things. So they thought front end, let us not waste too much time. We will just go along with this. Is the idea clear for everyone? Bhuvan, is the idea clear?
Yes, sir.
Okay, right. So does anybody remember that for your transistors, when you studied electronic circuits, there was something called as H matrix. What was it? Can anybody tell me? Bhuvan, can you tell me what was it in transistors? Did you study something called as hybrid matrix, hybrid parameters? Does anybody remember it? While studying electronic circuits? Does anybody remember it? Right. Okay. So if you have an idea of those things, HFE, I think you would have heard of this term, HFE. You always took it as gain. Right. And that was, suppose if you know the gain of the transistors or gain of the amplifier, you almost considered that as the HFE of the component. So that is what I'm just trying to do. That was just a mathematical representation. So any doubts with today's thing? S matrix formulation we'll be starting only tomorrow, but why S matrix? This is the small story there. Now I am just going to tell you which textbook to follow. The textbook to follow is right, microwave engineering. Microwave engineering by D.M. Poser. Right. If a soft copy is available, well and good. If it is not available, please tell me. I'll try to get you one. So latest student Wiley edition is available. I think they have also made it available. Right. So in this Poser text, right. So they have gone in one way. The introductory concepts on electromagnetics are there. Recommended read is to get a good feel of why we are studying this front end. Recommended read. Right. Give me a minute. I have to look into the chapter and then I will tell you which one, because there are differences between the old and new editions. Just a minute. Yes. Yes. So things have not changed. The recommended read is just go directly to chapter 4. Clear? The chapter name is Microwave Network Analysis. Right, and just start the introduction part. This will give you a really good idea of how to attack waveguide devices without too much electromagnetics. And this only resulted in this commercialized RF engineering aspects. So this is what we will have it for today. We will slowly stop the class and I am ready for doubts. It's almost 11:40 and I have been talking for nearly 30 minutes. I don't know whether you guys have got anything or not. Is the idea clear? S matrix, because tomorrow when you start S matrix formulation, you should be really clear. Clear? So there should not be any doubts regarding why you want it, what you want it and all. Everything should be pakka. You should appreciate the things. That is what I want. So maybe here you should get an idea of some terms called equivalent voltage. Equivalent voltage. Equivalent currents. These things you should get a feel of it. Please read it because the next class I think can be had only on Tuesday first hour, isn't it? So please understand that, and we are having big gaps because of the lab sessions. So try to be in focus and read this chapter 4 introduction. That's what I would like to tell. Then you will get a good idea of what we discussed for the last 3 classes. Right, so the class is stopped officially and it is open for questions. Those who want to leave can leave. Yeah, and I'm ready for questions here. Yeah, please.
So is there any particular edition for this book or like any edition will do?
Yeah, but almost though the initial chapters are all same, I think, because I have got something called as Wiley Student Edition. Even the older editions, I think everything is same. Only from the later chapters, I think things become different. The first 5 to 6 chapters are same. Don't worry. You get any of the editions, no problem. Is it okay?
Yes, sir.
No, at present only for the first 2 units of the syllabus, any edition is okay. I think in the last part of the textbook only certain changes have been done, which I will intimate you. That is corresponding to our second half of the 3rd unit. Don't worry till that aspect. They have added some advanced things in the new things. That's not a big issue. That when I meet that, I'll tell you. Anyway, you can get this. The first 3 chapters will be on basic electromagnetics and transmission lines. Just give a fair, good read through it, please. That is what my advice. So that it will be you will be ready for the things. Right. So those who want to leave can leave. I'm just going to meeting for your questions, because today's class is also a bit of descriptive class only. Next, when I start the formulations, you will know what we are trying to do. Right. Vinuja.
Sir, yes, sir.
Any doubts till now? Not only in today's class, till now?
No, sir, not as of now, sir.
You are clear with the foundations, why you should study the subject?
Yes, sir. Yes,
okay, good. Akshay Reddy.
Hello, sir.
You're okay?
Yes, sir.
Okay, good.
Yes, sir.
That's there, no problem. Just wanted to discuss one thing. Have you heard of this mobile number portability? Has anybody? Saran.
Changing of number, sir.
Changing of number. So, Rahul, how are they able to do it so seamlessly?
I think changing from one like home host to the foreign location.
That's all. See, understand, because only they are changing only in the baseband. They are nothing doing with the front end. Okay, again and again. I'm just putting it again. All these schemes, they come into picture because whether it is Jio or Airtel, the front end is same. Okay.
Sir.
I told you, no, GSM handset.
Yes, sir. Architecture.
As long as you have that, actually, this should have been brought 10 years ago itself. Getting it?
Yes, sir.
Right. And for the entire class, I'm telling, even if you're changing from Videocon to D to maybe Airtel or from Airtel to Jio TV, There is absolutely no need for you to change the antenna and all. In the set-top box, previously there used to be a card. You can just change that card. That is enough. But these guys just try to impose their antennas, transmission lines, and all these things on us. Clear. Actually, if you can have mobile number portability here, you can have those things there also. Because the front end is all same. Don't worry. D2H application means the front end is same. But see how the business goes. Clear. So just try to get a feel of this. This front end is really an issue. Then I think, Aditya, I think I told in the class, this charging. Mobile phone when you change, why are you required to buy chargers, isn't it? I think I discussed it in the class because one end of the charger is same. At least in India, it is the physical point. The other end, why are they changing it? Just to make money. They don't need to do it. The Bluetooth, if you want to buy a phone, just go and buy change the phone alone. Why are you buying all the associated accessories? Right? But this is what the problem there. We are creating e-waste as well as buying unwanted things. Right? So this is the problem with not being standardized. So as people who are passing out, you have to have an idea. Don't unnecessarily change phones unless otherwise it is required. Right? So, okay. So it's 11:45. We'll stop here. Anything you want to discuss?
Excuse me, sir.
Yes, sir.
Sir, this is regarding the attendance. I was able to join the class at 11:10 only, sir, because of a placement exam.
Placement, I know what happens. No problem. Don't worry.
Oh, okay, sir. Fine.
See, attendance, if there is no placement, I request everybody to come on there on time. Clear? Yes, otherwise, the recordings are available. Please go through it. The CAR will give us lists on who attended the test and all. That will take time. Well, I am also not going to insist on that. But please take care. Listen to the classes. Don't get a break in between. That is what my request.
Okay, sir.
Okay.
Thank you.
Right. If that is the case, I am stopping the class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.